Good day, I am Carl Joseph Montierro and I am here to discuss DBSCAN. We will use DBSCAN in our customer segmentation dataset and we will use this DBSCAN as our clustering algorithm. So first, what is DBSCAN? Imagine you're using a customer dataset for mall marketing, trying to target the right customers with the right offers. DBSCAN helps by automatically finding groups of customers based on their shopping behavior or preferences. It works by looking at how close customers are to each other. If enough similar customers are nearby, DBSCAN groups them together. Those that don't fit, they are marked as noise or potentially unique shoppers or outliers. What we will be tackling in this video is the selection of features, choosing the optimal epsilon and mean samples for our DBSCAN, the result of our DBSCAN, and the marketing recommendation based on our DBSCAN. So for the selection of our features, we choose annual income versus spending score. Why? Because of its relevance to customer behavior, simplicity and interpretability, comparison with other features, and actionable insights. Annual income indicates the customer's financial capacity, which directly influence purchasing power and product preferences. And spending score, it reflects purchasing habits and loyalty, a crucial measure for designing effective marketing strategies. And we also choose annual income versus spending score because of its simplicity and interpretability. Clustering with two features create distinct and easily interpretable segments. For the comparison with other features, adding age introduced additional complexity and increased noise points or outliers. And while age can refine demographic segmentation, it diluted the focus on spending capacity and behavior, which are more critical for targeting in a supermarket context. For the actionable insights, these features combination directly aligns with marketing goals, such as differentiating high spenders from budget-conscious customers. So next, choosing the optimal parameter. DBSCAN uses two parameters which are epsilon and mean samples. For epsilon, it is the maximum distance between points for them to be considered neighbors. And for mean samples, it is the minimum numbers of points required to form a dense region or cluster. So we will use this to know our optimal epsilon. And based on this elbow, we can see that it is more optimal in between 0.3 or 0.4. So we use 0.4 also for practicality. Broader clusters ensures most customers are included, enabling quick and effective marketing deployment. Now we will apply DBSCAN after finding out the optimal epsilon and the mean samples. So here we can see that we set the optimal epsilon for 0.4 and the mean samples to 5. And after that, we will input it into our DBSCAN. We will use 0.4 for epsilon and 5 for our mean samples. And we will create a clusters. Now to visualize the results of our DBSCAN, we will use these codes and we will plot the result of our clusters. Now, this is our cluster. The annual income versus spending score in DBSCAN. We can see here the different clusters and the noise of our datasets. And to analyze how many clusters that our DBSCAN have created, we will use this code. It can identify the number of clusters and the number of noise points from our clusters. So from our 4 clusters, we can identify those types of customers, such as high income, high spending customers, and low income, low spending customers, and middle income, high spending customers, and middle income, low spending customers. And the other part is the noise points or the outliers. So for the marketing recommendation for our first cluster, which are high income, high spending, we can promote a luxury products, exclusive membership, and premium services. And For low-income, low-spending customers, we must focus on discounts, value bundles, and loyalty rewards for frequent small purchases. And for middle-income, high-spending, we can use limited time promotions for them. And for middle-income, low-spending customers, we should offer a value for money deals to increase basket size. And for the other part of our dataset, which are noise points, they are the outliers with inconsistent purchasing patterns. And we only have 15 customers which are our noise points. And for them, we can investigate for potential unique segments or exclude them from core strategies to avoid inefficiencies. So overall, the DBSCAN clustering with 0.4 epsilon was selected for its balance of inclusivity and practical segmentation. By focusing on annual income and spending score, we identified actionable clusters that align directly with marketing strategies. The recommendations provided can maximize customer engagement and drive revenue through targeted campaigns. That's all. Thank you for listening.